Does that mean we're supposed to start? Okay.
Okay. Hi. Welcome. Oof. I know you're probably a little bit too excited right now to say anything, but it will be a casual talk. Hi.
Hello.
Thank you.
Better.
So, who has used IdentityServer? Cool. So, who is using IdentityServer free? Almost no one. And you're all using IdentityServer4 already? So, who's using 4? Who's using free? And where are all the other hands that just said they're using it?
Maybe 2?
Maybe 2? Really? Okay. Okay,
Yeah,
good.
okay.
So, this talk is mostly about the delta between IdentityServer3 and IdentityServer4, the things that have changed. If you never used it before, you will still get something out of it because you see how we're going to set it up and all that. At the same time, I think it's also a story about how ASP.NET Core has changed in comparison to Katana and ASP.NET that allowed us to leverage features that are now in the platform which didn't have existed before. Okay, so it's a bit of lessons learned and what did we do and how maybe even how did we fail. So basically, like I think 1.5 years ago, the Microsoft ASP.NET team approached us and said, you know, we're going to remove a couple of our components from the system, especially the ones that produce tokens. We're going to focus on the consuming token side of things. And they said, like, are you guys willing to fill the gap and update IdentityServer in the same cadence, kind of, as we update ASP.NET Core, so people have something to build their token-based solutions? And, you know, we were young. Needed the money, I guess. There was no money, but we were young. Said, yes, we're going to do that. And, you know, we tried to keep up with the changes that happened in ASP.NET Core by the time and, you know, build stuff. And then they changed something and we realized, oh, that's something that's breaking us. Build stuff again. And, you know, a couple of months ago, it was released. ASP.NET Core and IdentityServer was released. End of December. So we try to stay as close as possible, but it's kind of hard if somebody changes the platform all the time you're running on to write some meaningful software on that. So basically, yeah, this is kind of like what has changed between 3 and 4. Where did we end up?
And we ended up old now, right? We were young before, and after all the
all the gray hair. I didn't have that 1 year ago, so you know. So maybe the first thing that's new is we have a website. Yay! That is kind of like the starting point for everything you want to know about IdentityServer4. It, you know, gives you like a high-level overview, blah, blah, blah. But really the important things are you can go to the source code from here. Yeah, we have documentation. You can go from here. We do training on ASP.NET Core security in general and IdentityServer in particular. We just did that on Monday, Tuesday, so you can see the schedule when this is happening here. We do consulting. We have production support, which is new, by the way, something we worked with partners on, that if you want to put that in production and, you know, you can sleep better if you know there's an SLA around that, then that is also possible now. Maybe jump to the source code first. So that's on GitHub. It's in our organization. It's called IdentityServer4. Scroll all the way down. It's all the way down. It's a .NET Foundation project. Have you heard about the .NET Foundation? It's basically, well, a foundation for .NET-based projects. I guess that makes sense, yeah. And also, since a couple of weeks, you can certify your implementation of OpenID. So in other words, you can go through a testing process and they make sure that you implemented the protocol in the right way, so you are compatible with other implementations of other vendors. And that also means for you guys that if you use IdentityServer, it's not you're locking into a proprietary implementation of the protocol. You know, this proves basically that we just behave as any other certified implementation of OpenID Connect. Okay, so I want to show what we have, the source code.
Sure. So to sort of model the scenarios that people moving from IdentityServer 3 to 4 is, people may have put out IdentityServer 3 a year or two ago. You might be using it. You might have older MVC, Katana applications using it. But we found, people are now starting to build more and more ASP.NET Core applications. And so, of course, they want to secure those. But you have IdentityServer 3 in place. So what we have is a little bit of...
Which is totally fine, by the way.
Yeah, absolutely. So we have a little bit of a sample here, demonstrating that setup. So what we have here is an IdentityServer 3 host, pretty bare bones, just to show you the basic moving parts. We have a web API that we're going to be invoking, and then we have a couple of applications, clients using that API. We have a console client that's sort of simulating a scenario where you're going to have a server-to-server communication. There's no human involved. You just need to call an API, but do it securely. And then we also have an MVC application where a user can log in and then log into the MVC application, get an access token, and then on behalf of the user, invoke the web API. So I guess we can just run these here real quick to illustrate them. So here's just my web API. We're just hosting them in console applications. The web API is pretty simple, just a straight-up controller. We're going to echo back the claims that come in from the token. These are all, by the way, ASP.NET Core. So to protect your web API, what we're using is our authentication middleware. This basically wraps Microsoft's JSON Web Token middleware, but we add a few other features on top of it, like reference token support. So this is our web API. Console application is pretty straightforward. This is using what would be known as a client credential flow. So main just comes up. We're going to go get our token on behalf of our server-to-server communication, and then invoke our API with it. So I guess we can actually just run this one first to see that it's working. And really, all this did, I'm not actually running Identity Server. Okay, let's do that first. So here we have our IdentityServer 3. Actually, while I'm here, I guess I can poke through the config. So we have registrations for both our console application and our MVC application. And then down below, we have the user data that we're going to be exposing to our MVC application. When the user logs in, the app may want the name and the email. And then, of course, this models our API. So I think if I can run this first, that's IdentityServer 3 now running. Good. And now I run my console application. Okay, so basically the console app launches, goes to IdentityServer first, gets a token, and calls the web API. Great, that all works. And then our MVC application.
Oh, by the way, if you have any questions in between, just give us a sign.
So the MVC application now wants to log a user in. So we'll go to our secure endpoint. This is redirecting us then first to IdentityServer. The user's going to log in there, get their single sign-in, or if you want to do your Google logins, we can do that. Here's our consent screen. And then we're back into the MVC application. All right, we've now authenticated. We know the user, their name, their unique ID. And then we can invoke our web API, again, on behalf of the user. So the web API knows who is invoking it. So that's the setup. Those are some of the common use case scenarios. So building new applications, this pretty much models that. So what we're going to do next is take the IdentityServer 3 as our OpenID Connect provider and just move the configuration over to IdentityServer 4, and we can see what's different.
So I guess the most fundamental thing that is different is the hosting. Yeah, so in IdentityServer 3 was hosted on Katana, right? And Katana was this add-on thing to ASP.NET, which had either an IIS-based hosting model or an self-hosting model, for NT services or console applications like Brock is running here. The fundamental difference in ASP.NET Core is that you're always writing a console application. That the notion of a web application as we know it from Visual Studio doesn't exist anymore, right? You want to write a web application, you basically write a console application which happens to have a web server. Okay, so let's have a quick look at the old hosting code. Yeah, so the old hosting code, basically, you use this thing called web app. You passed in a base URL. You passed in a type name for a class that holds the configuration of that HTTP pipeline, and then you called start on it. Okay, and that was just an option in Katana. If you wanted to do IIS, that used the IIS web config and the way it works in ASP.NET. So now switching to and maybe the other hosting concern that exists here is logging, right? So logging is a hosting concern. Because in Katana or ASP.NET itself, there was no built-in logging infrastructure, right? I mean, you all know that if you're building applications, you come up with your own logging mechanism somehow, right? And there are frameworks for that and so on. And we use something called liblog. Has anyone ever used liblog? Yeah, a couple of people. Damien Hickey, good guy. And the idea was that basically you as a library developer, you don't want to assume a certain logging framework, right? We just want to log stuff out, but we want to give you the freedom of using your favorite logging framework. Yeah, and that's kind of a not so easy thing to solve. And liblog had this approach that you basically had an abstraction of a logger, okay? Because they need more abstractions, right? And we were just logging out, and then liblog was picking up whatever at the hosting level, which logging framework was configured. And that was a bit of magic. It was poking around in the loaded assemblies and used reflection and all that stuff. So how does that look like now in ASP.NET Core? So ASP.NET Core is, as I said, a self-hosting model only. So your application will always be self-hosted. It will always be a console application. And then you can either run it self-hosted, like we are doing here in a console window, or you run that same code in an NT service, for example, or there's a special integration piece if you want to run it from IIS, right? But IIS is not special anymore because ASP.NET Core is cross-platform, so the role of IIS could also be taken by Apache or Nginx or whatever web server you want to put in front of your application. And that is pretty much the same model as being used by Node.js, for example, these days. Same intent, different keystrokes, I guess. You're building a web host builder. You tell it where to run, which server to use. We were using Kestrel here, which is Microsoft's cross-platform built-in web server. We set the working directory. We say if there is IIS, use IIS integration. Again, same idea. There's a class called startup that has the configuration, and then we say build and then run on that, and that's a blocking call, and this will bring up a web server, and our application will start taking requests. So now, how did startup look like in free? So in free, in Katana, they have this thing called the app builder, the iApp builder. So you have a class called, you can name it whatever you want, but it must have a method called configuration, and it passes in an iApp builder, and this is basically the thing that configures your pipeline. Okay? So, and then you can wire up what is called middleware in that pipeline, and one of the middlewares, in that case the only one, is the IdentityServer middleware. So that's a piece of code, our code, that runs in the HP pipeline and processes the requests going to IdentityServer. A very common pattern in Katana was that you basically pass in an options class into the middleware, which configures the whole middleware. Okay, so that's the thing called the IdentityServer options here, and that was basically our only, if you like, top-level configuration object, and from that, all of the configuration hang off. Yeah, so for example, your site name, which signing certificate do you want to use? Do you require SSL? All kinds of more options. There were tons of options. Yeah. The point is that, and that because we'll see that'll change, all of the configuration in Katana happened at the middleware layer, and this is changing in ASP.NET Core. The other thing which is interesting here is this class called the IdentityServer factory. And the factory is our own DI system. Now you might wonder, why did you guys have an own DI system? Yeah, isn't that a stupid thing? The problem was there was nothing built in Katana. Right? ASP.NET before, or Katana, didn't have a built-in dependency injection container. Okay? So we took the one we liked the best by the time, which was AutoFac, and just, wrapped that up in our internals, kind of, and the factory was our abstraction of that DI container. So basically, on the factory, you had like extension methods, and you said like, okay, register something that gives us clients, and register something that gives us scopes and users, and there are many, many more extension methods. And oh yeah, you can see there are all kinds of things. But basically, all the extensibility points could be plugged into this factory class. And again, under the covers, this is nothing else as assembling an AutoFac container at startup time. Okay? So let's have a look how that changed in 4.
Well, we don't have anything yet.
Oh,
so,
yeah, right.
So we're gonna code this up. But yeah, so the big change here with ASP.NET Core is that dependency injection is built in. So what that means is that our factory object that we used to have in 3 goes away. Right? We actually removed a lot of code from IdentityServer4 when porting over to 4 because we could rely upon the platform services of ASP.NET Core. So the logging is also one of them that went away. Dependency injection, that was another big one too. So basically the first thing we do here is we need to put, well actually to talk to the new method here. So there's a new method called configure services, and this gives you basically the container that you're going to register any of your services in. And so this is where then you register things for DI. So as is the pattern, what we have is an add identity server extension method off of the service collection, and it is to this one line of code that puts in all of the necessary services that we need by default. So in the past then, when you needed to override a feature or extend the functionality, you had to register your own implementation on our factory. Now all you have to do is take your implementation of the iClient store or whatever the extensibility point is and just stick it into DI here as well. Okay? We do have some extension methods off of this for adding various things. So we have some convenience functions to easily wire up the right thing. But again, it's just putting things into DI. So you can just configure things yourself if you want or use these extension methods.
And the middleware itself, just to conclude that, they split up this startup class in 2 methods, as Brock said. One is for configuring the DI system, and one is for configuring the pipeline. Okay, so the typical pattern in ASP.NET Core is that sufficiently complex middleware has 2 parts. One is the upper part where it adds the DI services, and the lower part where it inserts itself into the pipeline. MVC, for example, uses the same pattern. Okay, so and now it turns out, since all of the configuration is happening at the DI level, there's actually not a single config option anymore on the middleware itself. Okay, so we've seen in 3 we had to load an X509 certificate from somewhere and stick that into our options class. And what we internally did is really we put the options class into the DI system. Right? So at any point in time when we needed to load the certificate for signing a token, we went to the DI system, got the options class, went to the signing certificate property, and got this thing. Okay, so how would that conceptually look like in 4 now?
Well, we're going to put that into DI off of our add identity server. We have a helper here for add signing credential. That would be one way. Okay, so
and again, yeah.
This has several overloads depending on where your key material is coming from. So you can just find your own RSA security key or your own X509 certificate, for example. And then I think we have even another helper here that even allows us to fetch the certificate in the same way that we were actually doing in IdentityServer4. So over here in IdentityServer4, we had a helper to look that up from the local machine certificate store, and that pretty much is just wrapped up into this other overload.
And technically, again, this implements an signing credential service in the pipeline, in the DI, right? Which returns you the certificate you stick in, right? But that's a very common pattern you'll see in ASP.NET Core in general. There's another method here called add temporary signing credentials. So we had a lot of, we got some feedback saying, all this certificate stuff is too hard for me. Can't you just create a key for me and I don't have to think about how that works? That's this guy. Okay, so when you're saying add temporary signing credential, it will create a random key pair at startup time for you that you can use to play around. You know, you don't have to wait for the admin to hand you the magic, floppy disk with the certificate on it. And but this is only for development time, really. So never ever use that in production. You will not find that a pleasant experience. Yeah. Okay, what else do we have?
All right, so the prior one, we had to configure then, the other configuration here. And again, as traditional with IdentityServer, we had to teach IdentityServer about three things. One were your clients, those are the applications. One was the users that needed to get authenticated. And then the other thing were the scopes, which were the resources that are being protected by IdentityServer.
So, let's start with the scopes. Yeah. So one of the big changes we made pretty late in the game was so we've been for the last 2 years or so we've been teaching OpenID Connect and we've been consulting people and people immediately get what a client is, people immediately get what a user is, but the scope concept in OpenID Connect is a bit confusing. So we found ourselves over and over saying, think of a scope as a resource. And there are two types of resources, identity resources like first name, last name, and there are API resources. And then at some point said like, why don't we just call the class resource and we don't have to explain it over and over again? And that's what we did. Okay, so we renamed scope to resource. Scope is the term that is used in the specification and we just try to be true to the document, but it turns out that it's just in the way when you're modeling your architecture. So now we have two types of resources in our system. One is called an API resource, which is an API you want to protect, right? And one is called an identity resource, which is, things like first name, last name. Yeah? And we're going to start with an API resource first. Now, the other thing that hasn't changed is you can still load your configuration data from wherever you want. Yeah? So if you want to use a database, we have an entity framework service for that. If you want to use a config file, then you load from the config file. We have a couple of customers who want to use it in code and just use continuous integration to update their configuration or something in between. Yeah? And again, technically speaking, there's an I resource store, and you implement your favorite implementation of that in the DI container, and that's what we're going to use. Yeah, we have a built-in one which is useful for testing and for development time and for doing demos like this, which is the in-memory resource, API resource, right?
Oh, static.
Okay. So you just define the APIs you want to protect, you pass them into our configure method, and from that point on, we can now reason about these APIs when somebody asks for tokens for them.
And so if you've been using these protocols and you're familiar with requesting scopes, that's exactly what this is creating, right? This API resource models your API as a whole, and these constructor parameters are indicating that's going to be the name of your API resource and the scope that is going to be requested by a client application to access that resource.
And this line of code actually models the most common scenario. You have a logical API, which you want to assign to a scope name. Okay? This API might consist of multiple physical endpoints, yeah? But you want to give it a name that clients can ask for. What this model also enables is a much easier modeling of more complex scenarios. Yeah? So just quickly create another resource that has multiple scopes, for example. Yeah? That was a bit, sometimes a bit complicated. So create a more complicated API, right? Maybe the calendar API, whatever. Or the complicated API, right? And then you want to have multiple scopes that refer to the same API, but maybe you want to have like a full access scope and a read-only scope, for example. Yeah? And then you can do that. You can configure, when somebody asks for a token for this scope, which claims should go into that token by setting the user claims, I think it's called, collection. And the idea is now that when, regardless of which scope you're asking for, the token will always have name and email. But you can also now configure, if he's asking for full access, in addition to that, add another claim, like one that would only be able included if the client is asking for this additional scope. Okay, so yeah, this model we think simplifies how you can model APIs in IdentityServer. Okay, so you just comment it out. We don't need it really. Okay, cool. So now we have a resource. The next thing we need is a client that can use that resource.
This configuration didn't change as much, so we might be able to get away with copying most of this. Okay, so that looks about right. Client ID, client name, flow.
Flow, we have renamed flow. So when we started learning about OpenID Connect and OAuth, we realized that there are certain flows in these protocols that, when used together, can create security problems. Like, for example, you are allowing a client both implicit flow and authorization code flow. Authorization code being the more restrictive and more secure one, but if you allow both for the same client, somebody has just fiddle around with the query string parameters and downgrade the security from one flow to the other. So we thought a safe default would be to just allow one flow per client. Okay, and that's what we did in IdentityServer4, just defensively coding all that. Yeah, it turns out there are situations where it actually makes sense that more than one flow is allowed per client. Let's say, for your MVC app, it wants to act both as an implicit client, but also wants to do server-to-server communication. So we need client credentials and implicit flow, or wants to use some custom grants, whatever. So we kind of relaxed that restriction. You can now define more than one flow per client, but still, when setting it, we run some plausibility checks in the background, making sure that you don't choose vulnerable combinations of flows. Okay? So for the most part, you should be fine. If not, you will get an exception at startup time saying, hey, that's not secure. Okay?
Good. Okay, so I think all we have to do is take this guy and put him into our in-memory implementation as well.
Oh, a couple of more things.
Okay.
Well, actually, no. Just write the client first. Or look at the client. So yeah, so that should be it, right? For
client credentials, where there's no human involved? Yeah.
Yep.
Okay. So let's shut down IdentityServer3. Let's now run IdentityServer4. Let's see here. Actually, we'll just kill them all. Okay, there's IdentityServer4. Again, rerun our API. Again.
Go back to the client code first before you run it.
What did we miss?
No, to the client code.
Oh.
Console client.
Yeah.
A couple of things I want to point out that we also changed here. So when you scroll down, when you get the token, so there's this, this class called token client, which is our client library. You don't have to use that, but basically what Brock's passing in here is in the token client is the address to the token endpoint, the client ID, and the client secret. Yeah. Another thing that the OAuth spec allows per specification is having clients without secrets. Yeah. Again, being a security guy, I thought like, that sounds wrong to me. Again, it turns out time will tell, and you get more experience. There are situations where clients without secrets actually make sense. For example, for publicly deployed clients, right? Your JavaScript client, well, maybe, but also your native clients you deploy in the App Store. What's the point of adding a secret to that client? That secret is in the source code. Yeah. So we just force people to manage more secrets, even if they weren't really secret. Yeah. So again, a new feature in 4 is you can have clients without secrets. Okay. That was a lot of feedback we got on that. Yeah. The other thing is when Proc is requesting the token, he passes in the scope. Yeah. In 3, scope was a mandatory parameter if you want to get a token. Again, we got feedback saying, you know, in my data center, I have all these clients and all these scopes, and whenever I give that client access to another scope, I have to update IdentityServer, and I have to update the client that he knows to ask for this new scope. So what we did now for client credential flow and for resource owner is, if you don't ask for a scope at all, you get all the scopes which are in the allowed scopes list. Okay, so this reduces a bit of the management, you know, the ceremony every time you're changing a configuration. Okay.
Good. So let me rerun the API, which I think I didn't. There we go. And now our console client, we used all the same configuration values. Most importantly, IdentityServer4 is now running on the same URL. So this guy should, hey, work.
Cool. Any questions on that? That server-to-server style communication. It's pretty much the same, just, you know, a bit more polished and a bit easier to use. Cool. The bigger, the more complex scenario is interactive applications, right? Where you have a UI and login and users, and we have to deal with humans and all that. So I guess the first thing we should do is add some users to the system.
Okay.
So we had a class called in-memory user in IdentityServer4, and it served the same purpose kind of as the in-memory stores. Like if you are in development mode, so to speak, right, and you don't have a database right here, but you want to have something to work with, yeah, then our recommendation was, yeah, use the in-memory user, and that simulates a user database. Yeah. Now, from the feedback we got and the issues that people opened is they started using in-memory users for their real users. So they asked us like, okay, how can we load the in-memory user collection from the database? I said, that doesn't make any sense. So we went back and forth, removed it all together, brought it back in, put it into a different assembly, added more comments to it, and we ended up with, in the end, calling it test user. I hope this makes it really clear. This is not for production, okay? So it's a test user, yeah? Besides that, test users, they are very similar to the in-memory users, yeah? They have a subject ID, they have a username, they have a password, and they have a list of claims, okay?
Good. We do have to register them as well in
Yep.
DI. Add test users. Good.
Okay.
Excellent.
So it starts to look more and more like the old version, just different.
Yeah.
Okay, cool. What's the next thing we need to let a user log in? That's the UI. Okay. Again, one of maybe the biggest point of feedback is that, you know, when we designed IdentityServer4, one of our design goals was to host it outside of IIS. Right? We have many people, customers also, that all they want is install an NT service on a server, and that is your OpenID Connect provider. No need to install IIS. Now the problem we were facing is, how do we implement the UI if we are not running in IIS? Because by the time, there was no good UI framework for server-side stuff that was running outside of IIS. And MVC was tied to IIS, and there was no solution inside. So what did we do?
We had to write our own.
We built our own view engine. Fun. Yeah? A view engine with templating and anti-forgery protection and
Layout template.
layout templates and ugh.
Yeah, so again, the nice thing in this version is because we can now rely upon ASP.NET Core, we can assume that MVC is going to work, especially cross-platform, and we're removing more code from IdentityServer4.
In other words, you now build the UI, okay? But using your favorite technology, right? Well, right now there's only MVC, yeah, but you know, there might be other UI frameworks coming to ASP.NET Core, and it's up to you really what you want to use to build your own UI. And to be honest, the UI is the thing you will always change.
Yeah, that was probably the most customized piece in IdentityServer4. People want their custom workflows at login time. And we had a little bit of a UI framework where we would show a username password screen. We could handle dealing with external providers. But if you wanted to break out of our predefined workflow, you could do it. We had a way to exit that workflow, but you had to come back and kind of coordinate with us, and that was, a bit of work. So we just decided, okay, no UI, that is the most customized piece. People have all these different requirements. Let them write all that code.
So, does that mean you have to write everything from scratch? No. Okay, so there are a couple of different ways how you can start building your UI. Well, you can start from scratch, yeah? So, or maybe you have an existing application, or maybe an existing login page, for example, that you just want to carry over, then copy it to IdentityServer. We wanted to make it as easy as possible. So, for example, another valid approach would be to just start with the standard MVC template with the login page and just add the IdentityServer middleware to it, and that will also work, yeah? So the way the UI works is, a request comes into us, we just do a redirect to /account/login, and that's configurable, of course. And behind that URL, you can do whatever you want. And when you're done with whatever you want, you're setting the authentication cookie and redirect back to us. And then we continue the protocol work and just do, issue the tokens and all these things. So it's totally up to you now how complex, how easy, how look and feel you want to do in between. Okay? Now, there used to be a thing called NuGet content packages. You get a NuGet and it spits out files, static files into your project. That's gone. Yeah, that's kind of like one of the victims of the the whole change between .NET Core and all that. So what we did is we created a repo on GitHub called the IdentityServer4 UI quickstart.ui. And what this contains is only the UI pieces. Yeah, there's a sample login page in there. There's a sample logout page in there. There's a sample consent screen in there, and you can just download that and just copy it into your project and use it as a starting point. Yeah, bootstrap and all the bells and whistles. Yeah. So either that, or we have a little script file that you can just execute, and it will just download the folders into your local directory. Okay? So what do we get here?
So what we do is we have, as Dominick mentioned, we have like a login page. It's just to get started. It's sample code. You can go and this is, start from here and tailor this as you need. But the main pieces of UI that IdentityServer needs are, sign in and sign out capabilities. So we have an account controller for those sort of things. Also, the account controller helps deal with integrating with the external providers. If you want to plug in Google or Azure Active Directory and have those users come back and authenticate through IdentityServer, you have to have some amount of code to coordinate from the external provider back to your matching account in your database, and then, of course, issuing the cookie here. So there's code in here that deals with sign in and sign out. The only other pieces of UI, we have the consent page as well, which may or may not be appropriate for all scenarios, but if you need a consent page, this will get you started with that. And then I think we just have a home page and an error page. So that's pretty minimal UI, and it's the sort of thing you would build in your, obviously in whatever login system you need to. We have the associated views here. There's not much there. We have some styling, so there's some www files with CSS. Within the account controller, because this is the place you'll probably write most of your code, we have, first of all, the constructor is where we are injecting in the things that the login code needs. Of course, one of them has to do with your test users. So this is coded to deal with test users. So that's one thing that's injected here. Of course, you would replace this with your own library that did whatever database query to look up your users. So if you were using ASP.NET Identity, that would be the user manager from ASP.NET Identity. Okay? Another important thing that we inject here is something called the IdentityServer interaction service. So as part of the login process, you might want to know the context of the login, of the sign-in. Which client application was the user coming from? right? Aspects about whether or not you should be prompting them, or other requirements at login, like maybe a tenant was passed, or maybe a certain expiration on the login was passed along.
Or like a UI locale hint, like you have to show the login page in German or English or whatever. Yeah, all these things are made available to you via this service here that you can query.
So this is how you talk to IdentityServer from your login code. So then the first login is really, this is just showing a login page. When you post back, valid credentials and you validate them, we're basically going to, once you've done that, you authenticate the user. You issue the local cookie, and this is just using the standard cookie authentication middleware in ASP.NET Core. And then the other thing as part of this, of course, is, as Dominick mentioned, the workflow is your application needs the user to log in. So they first send the user to IdentityServer, and IdentityServer sends the user to your login page, which is this thing. We then pass you as a parameter where to send them back once they have signed in. So this is back into our authorization endpoint. So you have to maintain the return URL as part of your round-tripping the data in the UI. That's basically the last thing. Once they're signed in, you take them back. And then we continue the protocol processing and send them back to your client application.
And again, this can be arbitrarily complex. Yeah, this doesn't have to be a single page. You can have a complete registration workflow,
Two-factor auth.
Two-factor, whatever. Just hold on to that return URL because you're going to need it at the end to go back to us.
Right. Which is pretty standard in ASP.NET applications. So is that good for now? We're looking.
Yeah, for now.
Yeah. Okay.
We need to add MVC.
We didn't add MVC. So yes, this is of course using MVC. So we'll just add the normal services, add MVC.
Which is the same thing as us. Now they're putting their stuff into DI that they need.
Oh, we need static files.
Yep.
And we need MVC. I think those are the only few things we need to add.
Okay, so let's add the MVC client now.
And by the way, one more thing is we will register the cookie authentication middleware automatically, or if you don't tell us otherwise. But if you would like to control any aspects of the cookie middleware itself, then you can register it yourselves, and then as just part of our configuration up here in our options, you just tell us the scheme, and we'll just use that one. Okay, so that's another point that people wanted a lot of customization in the past on. I'm sorry, what did you say?
Let's have a look at the MVC client for a second,
Okay.
how we invoke that. So you see that basically here in the MVC client, we use the OpenID Connect middleware from Microsoft. So that says that there's a client called MVC. It has a secret. It has a response type. It asks for some scopes. So we now need to recreate the same configuration in IdentityServer4. The first thing we should create are the scopes, and the scopes don't exist anymore, as we just learned. So APIs, the API scope became an API resource, and OpenID and Profile, they are identity resources. Okay, so these are the two types of resources we are guarding with IdentityServer. So we need to register them. So one is OpenID. And by the way, OpenID and Profile, they are standard resources, if you like, coming from the OpenID spec, so we just have them built in. But obviously, you can create your own scopes and associate them with any claims you want to issue back to the client application. But for now, that should be good.
Okay. Oh,
cool.
And those need to get registered as well.
Yep.
Good.
And let's add the client, last step.
Yep, I probably can copy most of that from the prior configuration.
Oh, yeah.
So I don't feel like typing all those URLs in. So where did he go? Okay. Yeah, pretty much all that's the same. The only one is this.
You can remove 47.
Yeah.
This is something that we changed the default value for that. We have the redirect URI, so where is it going back to? We have the post-logout redirect URI, so where do we want to go back to after logout? We have the logout cleanup URI, we have a secret, and we have the allowed scopes. So pretty much the same. So the clients haven't changed that much at all. It's mostly around scopes and resources what we did.
Yeah. Okay, is that it?
And we made it a little bit nicer, yeah.
Yeah.
Cool? In other words, that should work.
Should. Okay, good. Let's run our API. Just to have that up. And the last one's the MVC client. Oh, I guess he's still logged in. Let's close that. Okay. And interesting. What did we forget? Add MVC, static.
Oh, with default route.
Thank you. There we go. And he needs to. Okay, one more time. There we go.
So that's the, the template UI or the sample UI. Looks pretty much like the old UI. That's the consent screen. Again, you can change that in whatever way you want. And here we are, back. So another thing that has, that has changed. You want to quickly show how you actually get the token now in ASP.NET Core?
Yep.
Because that is that's not an IdentityServer change, but an ASP.NET change. Yeah. So in Katana, you had to write quite a bit of code to handle various events of the OpenID Connect middleware, get the tokens from the request, and store them somewhere, and contact the user info endpoint. And these are now all built into the new middleware. So they are safe tokens. Safe tokens by default basically just takes the tokens coming back from IdentityServer and stores them in your cookie. To be honest, that's not a really good idea. It's a very convenient, demo-friendly feature. But if you store the identity token in there and the access token and the refresh token, maybe if you have that, your cookie becomes pretty big very quickly. And they are kind of masking that problem by having a clever cookie middleware that takes the, once the cookie gets bigger than 4 kilobytes, which is the allowed upper limit, they overflow into a second cookie, into a third cookie, into a fourth cookie until, or basically there's no more cookies left. So in reality, probably you want to store these tokens somewhere else, maybe in a cache or in a database, depending, how long you want to keep them. That being said, if you use the save tokens feature, there's an API hanging off the HP context. You say, give me a token, pass in the name, the access token, and then they give it to you from this property, from this magic property collection, and then you can use it to call the API. Which worked, right? You showed that.
I did run it, yes. Did I change something?
Did you touch anything?
Okay.
Okay. Cool. Any questions on that? That's interactive authentication using a web application and then calling an API on behalf of a user. Yeah? Pixie. So your question is, what about Pixie? Pixie is a specification which is targeted at native client applications, not native server-side applications. If you want to brief, well, we mentioned Pixie in the next talk when we talk about clients, but Pixie doesn't apply to web applications.
But we still do support it.
We do support it.
Yes.
Okay, so last thing missing, I think, is Google, right? Like, let's enable, in addition to username and password, let's enable Google authentication. How did that work in free? I can't even remember.
So in 3, what we had to do was, because we were coordinating a lot of the UI and the cookies, we had to be very clever about where external middleware was configured in the IdentityServer4 pipeline, because we had a bit of our own UI in there. So we had this little callback function where you could register, where you would register, whatever middleware, Google middleware or WS Federation or OpenID Connect to Azure Active Directory, whatever. But again, now in IdentityServer4, again, you can still, or you're still going to use the Google middleware to connect up to an external provider, but you just put it in the pipeline because now you're entirely in charge of the UI. So we will still need the Google middleware in 4. The other thing about this is there's a common pattern when you were using an external provider like Google, is that when the Google user came back into your application, you didn't want them to immediately be logged in with your primary authentication cookie. Usually you wanted some way to capture the user before you fully logged them in so that you could see, oh, this is Dominick from Google. Let's look him up in our database. Oh, there is a record. Okay, good. He's allowed to continue. Or, no, I've never seen this user before, so I need to show a registration screen or something else. So what we had is a second cookie middleware to hold that temporary cookie during this sort of process of identifying the user. Again, that's not really necessary anymore in IdentityServer4. You'll still use like a temporary cookie, but you'll just use your own. Okay? So that's what we need to have in 4. So let's go over to 4, startup.cs. We can then use the app.use cookie authentication. We're going to use a temp cookie of some sort. Automatic. Oops.
Is it below or above?
We need to add it. Hold on 1 second here.
So in the way the pipeline works in ASP.NET Core is order is really, really important. Yeah. So I always forget if we need to put the cookies before or after IdentityServer.
Well, what's going to happen is once they are done authenticating with Google, they are going to issue our primary cookie.
Oh, yeah, right.
And so because we're holding the primary cookie, they have to run basically between our cookie and MVC.
And at the same time, our middleware must be before your UI framework, which kind of makes sense.
So now we do have, again, in our quick start, our account controller has a little bit of code to deal with triggering this external authentication. So when you come in, well, I guess I should scroll back up. Our little extension method here to build the view model to show the UI, this will actually go and query, if I can find it here, all of the external providers that are configured in your pipeline. So in other words, this already knows how to detect Google or any other ones that you have. So our login page will now show buttons for Google, Facebook, Azure Active Directory, whatever. Again, that's all customizable. So then when we trigger that, that is down in our external code here somewhere. So this is what triggers the external authentication. Basically down here at the bottom, we're then triggering Google or Facebook or whatever. And then the callback occurs. And on the callback, this is where we're assuming the pattern of you having used the temporary cookie. So what we'll do is we need to go and query the temporary cookie to look at the Google user to find out who they are. So there is a little bit of coupling here. We need to know what name that's going to be. So we just have a constant for that. And that's essentially what the name is for this middleware here that we need to register, like that. So then when we use Google authentication, we'll do the authentication scheme. We'll call this Google. We'll then do sign in as, same constant. And then we need the client ID and secret. And in fact, I think we can just grab the same ones that we already had from here. Pop those in. Okay? So temporary cookie here to hold the temporary identity coming from the external provider to really identify them in your system. And then whatever other external middleware. And again, this works pretty much the same way for Google and ADFS and Facebook and, Azure Active Directory. Yeah. Okay, I think that's it. Mm-hmm. All right, so run it.
I think it's still running.
Maybe it is
the API.
Running. Yeah, it is. Okay, let's close these all down. Okay. there's the MVC client. So secure. Yep, Google shows up here. I'm already signed into Google, so I think it's going to come immediately back. Maybe not. Yeah, there we go. So we came back from Google already, and we continue on, and now we're back in our app. Okay.
Cool. So that's it. We ported everything over.
Yep.
So one very general thing that we often get questions about is, where can we use that? Where can we use IdentityServer4? It runs on ASP.NET Core, right? And Microsoft has a lot of marketing in these names again, so it kind of feels like ASP.NET Core is tied to .NET Core, right? But that's not the case, yeah? So ASP.NET Core, despite its name, can run on the standard .NET framework, starting with 4.5.2, I think, or something like that, or 4.6.
4.5.2.
Yeah, 4.5.2. So, in other words, if you have the feeling that jumping to .NET Core and everything new at once is a bit of a too long jump and too risky for you, you can just use your .NET framework and love probably and and know how to install and to manage and to troubleshoot, and your support staff knows about it and your customers know what's going on there, and you can just run ASP.NET Core on top of that normal .NET framework. Yeah. So that's totally fine, and that is, I think, also the most common scenario how our customers are using it today. Just take the .NET framework, run that on top. Yeah. If you are, want to make the jump to .NET Core, you get some interesting extra features that you won't get from the full framework. One of them is obviously cross-platform. So we actually build in parallel, every single check-in gets built on Windows, on OS 10, and on Ubuntu. So it's working, actually. You get support for things like Docker. Yeah, so if you want to run IdentityServer in a container, there's a guy who writes samples for that as well. So that's working as well. And maybe one of my most compelling features is that with .NET Core you can deploy the .NET framework and .NET Core itself with IdentityServer. So it's one self-contained install that you bring on a server. It doesn't need to have .NET pre-installed. You can run multiple .NET versions side by side on that server, and it's just a minimal impact kind of way to deploy that. Okay, what do you think? Is it okay? Good enough?
Good enough.
Good. Any more questions? Yeah?
Is it wise to write the UI for the IdentityServer as a single page application?
So the question is, can you write the UI as a single page application? Absolutely. Yeah. Again, what all we do is we do a redirect. When you come into us, we redirect to some URL that you configure. Yeah? And then you do whatever you want, as long as you, at the end, call a server-side endpoint that sets the authentication cookie and does the final redirect back to us.
I guess the problem there is that you have unconfigurable stuff, because you will be talking through the APIs to the single page application with IdentityServer, not IdentityServer, but the UI of the.
Yeah, that's always the problem. So writing a SPA is going to be harder, I think.
Sure. But yeah, technically, absolutely possible. It's just that, when you're done, you need to somehow trigger something that sets the cookie on the server and then go back to us. Okay? Good. Thank you very much for your time.
Thank you.
And enjoy the rest. Conference.